Box and whisker plots are most frequently used. We have seen them before when we were doing some quality control over our data, and we will look that figure by the end of this section again. So these are the representations where we split the data into quartiles. We divide the data into four different areas. So we have lower 25%, which we call it as Q1, and then we have 25 to 50%. We call it is to Q2. So Q2 is also the median, so it's where we have the 50% values. So its upper layer is actually represented in this box plot as a median line. We'll see this representation. And then Q3 is 75%, and then Q4 is the top 25%. So the body of the box plot consists of a box, so that is actually connecting this Q1 and Q3 with one another, and there are long whiskers. So these whiskers are actually the hair, the thick hair which are present on the body of cats or on mouse. So that's why this shape looks like looks like a cat or something. Here is the shape. So maybe these whiskers are somewhere in the middle. You have this cat which is seeing. So here is the box and here are its whiskers. So that's why this arrangement is called as box and whisker plots. So let's look into its different sections. So this is your first quartile, as I mentioned earlier. So this up till here, it's lower 25% of your data. We can also call it as Q1. Median is Q2. So up till here, at this point, the data has been divided or split into lower 50 and upper 50. So the top 50% is above that, and bottom 50% is below that. So this is exactly in the middle. So this is Q2 also. So up till this point, which we call it as Q3, so that represents your 75% of your data, and obviously the top 25% is right here. The box is drawn between Q1 and Q3, and in the middle we have this thick median line. So that is important to note, that this box is actually containing the middle 50% of the values. Then between this third quartile and the first quartile, we have defined another parameter. We call it as IQR. How the whiskers are drawn? In this example, the whiskers are drawn up till a maximum, starting and the lower whisker is still the minimum, but I will follow a different approach. We'll do that in one of the example I've selected for you guys. Here is the data set. So we have some numbers. So we take these numbers. Basically, this is just a data. So we want to get a picture or a shape out of this data. And let's see how can we plot it by using this box and whisker plot, and what we can infer from that while looking into that graph. Rather than just looking into this data, you cannot say anything. But when you put it in the shape of the box plot, you can speak about that data very well. So what we do next is we order this data. So we have the minimum value, which is 250, and maximum is 386, and total number we have are, in this data set we have 20 values. So number of observations is 20. What we do next is we trying to get the middlemost point. So obviously up till here we have this number 10 and number 11th values. So what we do here is we try to get their median. So since the numbers are even, we will take the median as n plus 1. So total numbers divided by 2 with observation. Actually, what I'm trying to say here is we will get the middlemost value, which will be average of this 10th and 11th value. But this is how you can use this formula if it is an even number. If it's an odd number, you can simply use n by 2. So that is actually our 10.5th observation. So we take those numbers 315 and 320 and we average them. So it's 317.5, which is our Q2, our median. We can take the average by simply summing up these numbers and divided by 20. So that is 317.8. How can we get Q3? So our data is split into two halves. So we can take the first half. So again, we have 10 values. So if we want to take the first quartile, the lower 25%, so that is obviously the median of the first half, and Q3 is the median of the second half. So Q1 is the average between 295 and 301, which is 298, and Q3 is the average between this 334 and 334, which is again 334. Interquartile range is the number. So that is achieved by taking Q3 and then subtracting Q1 from that. So it is Q3 minus Q1. So that is 334 minus 298. It's 36. Then we define some things which we call it as fences. So LIF is lower inner fence. So it is defined as Q1 minus 1.5 into IQR. So it's a number that comes to 244. We define another fence. We call it as lower outer fence. So that is Q1 minus 3 IQR, 190 in this case. Same way we define upper fences. So for that box and whisker plot, we are actually trying to get the outliers, the extreme numbers. So what those numbers are in those distributions are extremes. So they may be pulling the means towards them. So sometimes we want to remove those extreme numbers. We call them as outliers. So in order to identify them, we define certain fences around our data or around these box plots. So as we defined lower inner and lower outer fence, so same way we can have upper inner and upper outer fence. So they can be calculated with these two formulas. Okay, so in the end we have we are just plotting, so we are getting those numbers. So what we do here is there is a scale on the back. So we take our numbers. So this one is our up till here is Q1 and here is Q2. And then we draw between these two, we draw their box. We put median in the middle, and this plus sign is where we put the mean. So comparing mean and median gives us an idea towards which side it is skewed. If it is towards the right hand side, obviously it's skewed towards the right. So distribution is positively, a little bit skewness is there as far as this mean is concerned. So mean is there's relatively higher numbers towards the right which are pulling the means towards them. We draw those fences, those numbers. So this one was our lower outer fence 190 right here. We have lower inner fence which was 244, and then we draw the upper inner fence, so that was 388, and then we draw the upper outer fence. So once we draw those fences, now the question comes how to draw these whiskers. The procedure which I am following as far as this course is concerned, we need to draw these whiskers as the minimum number which is between those inner fences, the lower inner fences. So the minimum number between or before that lower fence is 250. So we draw the whisker up till that point towards this lower side, and towards higher side I will take the maximum value that is between this or before this upper inner fence. So that is 386. So we draw our whiskers. If we talk about these distributions, the distribution is seems like normal. We have the mean which is towards the right, so a little skewness is there, and the values are not showing too much variation from them, as we see that the size of this box is really small. So the middle 50% of the values, they are pretty close to one another. If the box size is more, obviously we can expect that data has more variation, right? Where are the outliers? So sometimes if we have some numbers coming in between these two fences, we can call them as mild outliers. We might use different symbols for them. And sometimes we have extreme outliers which are present outside of those outer fences. So those outliers, they play important role in those data analysis. So sometimes we try to get those numbers and remove them from our analysis. So this arrangement, box and whisker plot, looks like pretty cool, and it can rather than looking into those simple curves or waves or just simple looking into those tables, as compared to that arrangement, this box and whisker plot arrangement is really easy to see the trend of this particular distribution, as we see from here. So you might have seen this picture before in data quality. So here now I guess you will be able to understand what's going on. So we see those boxes. So in the middle we have this medians, and then there is a line which are actually connecting those medians with one another. So kind of that line which is right here in your figure. So with these what we can estimate is that we can compare so many distributions with one another. So in this case we have like 74 or 80 different distributions which are actually nucleotide positions, and rather than taking their normal curves, which is hard to compare, we can compare the data by using these box plots. We can look into towards left hand side. the boxes size are smaller. There is much variation. There is less variation as compared to the right hand side, where we have those boxes are really big. We have huge variation among as far as these quality scores are concerned. Even the medians are low. Same way if we look into the whiskers, they are really long. So that kind of arrangement, box and whisker plot, is easy, and in this arrangement we can compare many distributions with one another as we did in this picture. So a box and a whisker plot, or simply a box plot, we call it most of the time box plot also. So it splits the data into quartiles, and it can help visually compare different distributions together.